All right, guys, we're going to continue with these notes. So the next thing that we're going to do is evaluate logarithmic expressions without a calculator. So we have to go back and think about how you rewrite a logarithmic expression in exponential form. So what I like to do is I want this to look like the problems that we were doing before. So I'm going to set each of these equal to x, and I'm going to solve for x. So we take our logarithmic form and we first rewrite it in exponential form again. So log, the base in this case is 3. The exponent is x, and that's equal to the value, which is 81. Now you see these are going to be done without a calculator, so you just have to think 3 to what power is equal to 81? Well, 3 to the 4th is equal to 81. So your answer is 4. So the answer to log base 3 of 81 is 4. Okay. So keep going. So again, B. The base is 2. The exponent is what we're looking for, so that's my x, is equal to 1 over 32. Now, if I need an exponent so that when I raise 2 to that power, I end up getting a fraction, that means that my exponent had to have been negative. So think about 2 to what power is 32? So 2 to the 5th is 32, but we want 1 over 32. So my exponent had to be -5 because it's 1 over 2 to the 5th power. Part C. So the base, again, is 16 raised to what power is equal to that value of 4? 16 to what power is 4? It's not going to be a negative number because my answer is not a fraction. However, this time, if you think about it, the square root of 16 is equal to 4. And 16 to the 1/2 power is the square root function. So it's x equals 1/2. Okay. And now on D. So something that I neglected to mention last time when we talked about base 10. So I mentioned how if there was no base written, we knew that it was a base 10. Now just to add on to base 10, anytime we have a base of 10, it's also known as the common log. So if you hear someone say, or you hear me say in the future, we're going to do problems like this, whenever we talk about the common log, we have to know that that's a log with a base of 10. So again, I'm looking at 10 to what power is equal to 1,000. So the power is the 3rd power. Okay. Now I'm going to erase this just because I need to write there. All right. The next thing we're going to do today, and you can see that you're going to use your calculator for this, I'm going to show you what's called the change of base formula. Now, if you look at this right now, part A, log base 2 of 20. I need my calculator because 2 to what power equals 20, I don't know. Now, the way your calculator is right now, you could put this right in your calculator and you would be fine. However, in test mode, your calculator, you can't put this in your calculator in test mode. So the only way that you can put a logarithm in your calculator is if it's in base 10, okay? So can only use base 10 in test mode. So in order to use the calculator in test mode, we have to use what's called the change of base formula. So this formula says that if I have the log of any base a and the value of x, that I can take the log with any base that I want. I can choose a base of x and divide it by the log of that same chosen base of my a value. Okay, so this works for any value of b that is greater than 0, but it cannot be equal to 1. Okay. Now I realize it works for any base. We're not going to use just any base. We're going to use base 10 because that's what we can put into our calculator. So what you have to do to put this in your calculator, if you go back to problem A, instead of plugging this in my calculator, log base 2 of 20, I'm going to take the log of any base I want, 10 in our case, which I don't have to write because base 10 we know is the common log. We don't have to write that base. Of the x value. Well, the x value in this case is 20 over log, again, base 10 of the value of a, which is the base, in this case, 2. So you want to try to put this in your calculator and make sure that you get approximately 4.320. Okay. And you would just do the same thing. So for B, you would take the log, of course, base 10 of 12, and you would divide it by the log base 10 of 5, and you would put this right in your calculator and make sure that you get approximately 1.544. And then part C. So when I put the log base B, or base 10 of -9, over the log base 10 of 3, you're going to get an error in your calculator. Okay? This does not exist. That's because in our original log formula, if you go all the way back up here, it had to be for any x value greater than 0, meaning the value of x has to be positive. In this case, my value of x was negative, so it doesn't work, okay? X has to be greater than 0. And just as a side note, if you think about what it means, if I had, for example, the log base 10 of -9, that means that I'm taking 10 and raising it to some power, and I'm going to get a negative, which isn't going to happen. In this case, if I took 3 and raised it to a power, I would never get a negative number, so that's why this does not work. Okay. Now, just remember, as you're going through and doing these notes, you can pause this, you can go ahead, and if you have any questions, feel free to contact me via email or on Google Classroom. The assignment that goes along with this would be the rest of that first page of homework, so number 13 through 22. Okay, so you should be able to complete those now.